Hello and welcome. I'm Shadow of Shadow Gaming, bringing you Programming with Shadow, episode number 52. In today's lesson, we're going to keep going with our study of LINQ, looking at what methods are available and seeing how some of them work, and we'll just keep on going at it today. So, here we have our project from last time. It was just a place we were working through different examples. So, we have some different classes and things working around. So, what I'm going to do today, I'm just going to comment out what we currently got. Yeah, I'm going to comment this stuff out. And we're going to try to build up from here. I'm going to leave my list of people here. So the first one we're going to look at today, I think, will be, let's see. Let's try GroupBy. Yeah, GroupBy. The GroupBy, it's basically a way for you to group data into groups. I think a lot of times you'll see it buckets, but you're basically putting them by you're controlling them some method. So let's go to here and let's go down to our person and let's add a new field. Let's add a, I'm from the US, so we'll do public string state. This is just to give us another field to group by, so I'm just going to use the 2-character state abbreviations. I don't know what I pressed there. So yeah, so let's come up here and adjust this. So we'll do state we'll do Washington, New York, do another New York. We want a couple that'll group together. We'll do state, do CA, California, and we'll do a Texas. I'm picking bigger states for the most part. Let's do one more for, we'll do another Washington just to get group by. There's just 2 groups and 2 individuals. We'll play around with them for a little bit. Let's do a group by. So our groups equals people dot group by. We'll just do group by state. We'll do it like that. So that'll give us 2 groups. And the groups are I groupings, so we can see then. So the groupings are just string and person, so which state it is and which person. So what we can do is we can see how it groups them. So do it like this. Let's do for each org groups Waco palette. Palettes. I really need to turn it off. I hate it for this. Somehow it keeps messing up. See, this is sort of better. Whatever it did a minute ago was not better. So here. So we'll copy this, but let's adjust it. This isn't what I want to say. Let's do we'll just do age. We didn't do age. We did state, and then person. We'll just do name, and let's do a /t name. All right. So what we've done now is we've grouped each of the persons based on their state. So if we run this, what we will see is that I think it'll be alphabetical order. So we'll have California, then it might be order of when we got them actually. Let's see. Let's see what that does first. So there we go. So we got there it is. It's the order we received them in, so that makes sense. So there we go. So what we could do to make it alphabetical, though, we could sort them. So we could do people dot order by, and then our order by here will be dot state. Now, if we do it now that I think we'll get them in order. Let's see. Yeah. So there. So there we're composing a LINQ query. So we build it up as we went. There. Yeah, they're in order by name because that's the order of the list. Let's add another one to New York that's out of order. Let's do we'll do a Z, so maybe a Zach. That'll do. We'll just put it in New York. Now it's out of order, so let's see this one. So yeah, so that works, but it's out of order, so we can also fix that. So let's do this. So then by now we've got a three stages using what we did before. And look, now it's in the order we were wanting. So there we go. So in doing that, we were able to compose a really quick query, and there's not a lot to this. We're just group by order by state, then by name, and then group by state. And doing so, we were able to separate the list there. And if we had a whole lot of people like that, that's not a lot of code to do with all of that sorting. So that's group by. One thing to note with group by, if we look here at groups, we don't actually have any methods here. So when you're looking at it, it looks like a dictionary, which I think we've looked at. Basically a key value store, so you have a key and then a value. That's what it looks like here, just from how it is. When you're actually doing group by, though, it doesn't actually get ran until you run it. So we pass it into the for loop for each here. If we did a let's do this. Let's do a dot to list, and I think this will get us a list of those. Now, if we look at it, now we have a list of groupings, so we can still add groupings, but it's still the values are odd. So if we do 0 dot, now it still doesn't know what it is because we haven't actually went over the list. So one thing to keep in mind. Most of the time, you'll end up using it with a for each, and then the problem just goes away. But just keep in mind that you may not get exactly what you want out of it. Yeah, I think that's good. That's good enough. We'll keep going. Let's see. What did we not talk about last? Let's do join. So join. Let's see. Do we have? Let's do two. Let's do something new. Let's do another class down here. I could probably use what we've got there, but let's just make another one. Let's do customer. And this will be sort of similar. Let's have it prop int ID, and then we'll just have a name. Just something here for us to be able to test with. Do another one. Let's do public class order. And order will also have an ID. Let's do prop int ID prop int customer ID prop. We'll just do int. Should do double, but we'll do int. We'll just do total, just to keep it simple. Okay, now we have two more classes, so let's make some data up here. Comment this out for the moment. Control K, Control C, or not. Control K, Control C. All right, let's do this. So let's do list of customers equals this. We'll do a new ID equals 1, name equals. We'll just use the same names we've got down below. Just copy, paste. ID to Zach now because we switched the order. I don't know what I just pressed there. We'll get 3 AS. And just using the same names as below. So there's a customers. Let's do orders the same way. List order orders equals the new ID equals 101, customer ID equals 1, total equals, I don't know, do 50. Alright, let's copy that a couple times. Do 75. 25. Numbers aren't mattering here. I'm just making them a big enough gap. Alright, we'll say these two are the same customer. These. That. So we'll say 2 of them are the same customer. This one was customer 2, 3, 4 maybe. We may want one more duplicate. Let's duplicate a 3. Make this 6, 3, and we'll say this one was 100. Let's do 75 again. So there's 2 75s. Okay. So there's just little numbers to play with. So we have some data here. So let's do this. So we'll say var result equals customers dot join. And you've seen there was a couple of joins there. So we'll start with just join. So let's do this. So join. So the first parameter here, it's a little hard to read what this is actually asking for. First thing we're going to pass in is the I enumerable inner. So what we're joining with. So we'll say orders. Now let's do so the first one here is going to be the outer. So outer key selector. So that says what are we using as a key, and in this case we're going to use the IDs as keys. So we'll say C equals C implies C dot ID. Now we'll do the next field, which is inner key selector. So now we'll do O is O dot customer ID. So where they match. And then here, the next one is the result selector, how we make a decision. What are we picking? So we'll do C O again. I'm using those C's for customer, O's for order. And we'll do new, and then thing here, let's do C dot name, O dot total. There's a complex function, so looking at it, let's see. Let's do a We're gonna let it split it for us. Let's split it multiple lines just to be a little bit more readable. There. So there's a join. So if we look at the result of this, let's do this. So what we got out of it was an enumerable of something. So see, it's giving you a little weird indicator here. That's basically I'm going to say it's an anonymous function. I'm actually not 100% sure if that's the correct name for that, or an anonymous type, not function, anonymous type. But I'm actually not 100% sure if that's actually the correct name. But basically, it's representing whatever this data structure is, some kind of name and total pairing. So if we do a for each here, for each var v equals result, or v in result, cw v dot name and totals. Notice they're both there. So we'll do this. We'll do name and we'll do total. Let's make these equal so they just match the rest of the style we've been using. Okay. And I used V here because not really a good reason. I think of them as value pair because that's what I've picked here, but that's not necessarily true. You could have multiple fields here. Like if we added I don't know why you would need it, but we could add c.id as well. And now suddenly it's a three field thing. So value pair is probably a bad name. Let's just do R and result maybe. And I'll delete this too. But yeah, using join, you're able to combine these two in different ways. And if you had a lot of data, that can really make a lot of sense. So maybe if you had a database, it's basically doing the same thing as the join there. There we go. So there's the names and the totals. And notice there's no totals in this one and there's no names in this one, but we're able to combine them correctly. And 1, 1 matches this. 2 and the 2, 3s, 2 bobs. So yeah, so that's join. Join by itself gives you the list here, orders, and it's joining this into this. So we control how we do it. If we look at those other two joins, or left result equals customer dot join join. This one, let's see. So first field is enter. So same thing. So we'll do orders. Outer key selector will do the same thing. Let's grab this. And in fact, let's grab the rest of the fields. Order may be null. So if you notice here, this one, order is not null. So let's see if we get the same thing. I believe we do, but let's make sure. Let's see what happens. I believe they're the same. If we check the numbers, I believe that is what we expected. Yep. Okay. So yeah, so did the same thing. Anonymous type, I guess, is the name of what we're looking for there. trying to think what the actual difference is here, but just looking at it, I'm actually not sure what the difference is between these two. Left outer join, inner join. I'm gonna have to actually look that one up. We'll do a to do on this guy. To do and self what the difference in joins is. So I actually don't know right offhand. It's been a long time since I've used it. Anytime I've used join, it's almost always just been join. I'm actually not sure if I know the difference. I'll have to go try to play around with that and actually remind myself what this does. There's also the right join, and I think it's going to be the exact same thing, but it's going to do something slightly different. But honestly, I cannot remember right offhand. Just call it right join, right result. Now the C can be null, but again, I don't remember what the difference is. And the order is slightly different, so it's definitely something with the ordering and when you do them, but I'm gonna have to go actually look at that. So I'm not gonna try to finish this here. So joins, I'm pretty confident in joins doing what I think it does. I'm not confident on these. I'm gonna have to actually check these. Yeah, we'll come back to those two. So keep in mind join, and if you need to use whoops. And if you need to use the right and left join before then, read the documentation and test it. Because I am completely blanking on what it actually does right at the moment. Yeah, and reading the hint there wasn't helping me. Okay, yeah, we'll come back. We'll come back to that maybe next lesson. So join. There's also a left and right join, and I do not remember what they do. So keep that in mind, but might have to figure that one out. Let's do another one. I think I'm pretty sure I can remember. Let's use the same data we had before. We have your customer and orders. Let's use that again. So let's do another one. Let's do a SelectMany. So this one, I don't actually see this one used all that often, but it's actually really useful for some things. So let's try this. So let's make an example here. Var, we'll do customers again. Let's not do var. Let's do list of customer equals customers. So let's do a new. We'll fix the format here in just a second. New. Do one more. We'll do total, again, we'll just a gap. Okay. So customer, let's add a list of orders to a customer. There we go. All right. I think that'll make an interesting enough example. Yeah, let's just use the new format. Yeah, that's better. Let's do it the same way here. There we go. Actually, let's select the whole thing and move it back. There you go. I'm going to use that formatting. So what this is doing, we're creating a list of customers, and the customer has a name, an order. They also have an ID. We actually don't need the ID for this example, so we'll leave it at that. Let's add a second customer, though. We'll add a Bob. Just has one order, maybe. Let's do 25. I think this will get us to the point, but we may want to expand it. We'll see. So let's do a var orders equals customers dot select many. Let's do select first. Just remember what it does here. Select. This gets us an IEnumerable of a list of orders. So to actually use it, we would do something like for each var o in orders, for each var x in o cw x. So there, that'll print out. Maybe that'll do a printout. No, it won't. X is it x dot there. That's a print. That'll print out a list of order totals. And it does, but it's two steps. So the inner one's a list. So SelectMany gets around that. So let's do this again with SelectMany. So there's select or orders equals customers.selectMany. And this one, it'll look very similar. But now we'll do let's do a for each for o in orders. Now we'll just cw o dot total. And now we should get the same thing. What's happening here? SelectMany returns an IEnumerable of the orders, so it selects all the items and it flattens them into a single sequence. So it takes the list that would have been a sublist and makes it into one big list. The result of invoking the one-to-many transform function on each element in the input sequence. So basically, that's what it does. It's just flattening the list. So instead of having a list of lists, we have a single one, and sometimes that's what you want. And like I said, I actually don't see that one actually being used as often. I tend to actually see this one rather than this, but you can, sometimes this is what you want. You want to be able to take the list and flatten it, and SelectMany is the right tool for that. Let's see. I guess let's do this. Let's do just a show what it would look like. Let's do so here we have something like, let's say we have a customer, they have order. So after the SelectMany, however, move this up. After the SelectMany there, we just have a order. I guess there's 3 orders in this, right? No, there's 2 customers. There's some. Let's use actual values. Let's do Alice 50, 25, and Bob. Here we just had 50, 75, 25. So that's just sort of what's happening, is it's clearing it for us. So that's SelectMany. So another good one to keep in mind. Got one more. Let's try Aggregate. I've used it some, so we'll take a look at it next. We can collapse this. Let's do this. Let's do what was our function down here? We had a function. What was it? Evens? Yeah, is even. We'll use it. Let's do I don't think what I want to set up here. Grab this. I don't think what we want to set up. So let's do this. So let's find the even numbers again. So we've seen a couple ways we could do that before. Here's another way, I believe. Do nums dot aggregate. So when we look at this one has an interesting function as well. So it says it applies an accumulator function over a sequence. Let's see. Seed, you can specify an initial value. That's the one I want. So what I'm going to use it for is to I'm trying to think what I want to use it for, because I'm not going to get the list of even numbers. That's not what I'm doing. I'm getting some value from it. Let's do the let's do the count, I guess. So we'll just count the even numbers. So we'll do 0. So we're using a seed of 0, so that says start at 0. Now we'll pass in a function. The function's going to be a lambda. So we'll do you'll usually see it just x for single variables. I'm going to name these so I can tell what they are. We'll do total and next value. So then the function will just be even. Next value. So if it's even, then we will do total plus 1. Else we'll do total. I think that's what I want to do. And we're about to see if I got this right. I may not have. So let's see. So 1, 2, 3, 4. There should be 5 values here. So let's see if we get a 5 here. And we do. Okay. So what we did there is we made an accumulator function. So we got the count of the even numbers. So let's do this. So what we're doing there, we set a seed value. So the seed value in that case is the starting value. So where to begin. If we changed it, let's say we started at 10. So now we should get 15. That's what the seed value is doing, though. It's giving you a starting point. I've actually used that before to or had an adjustable starting point. So we were counting, and we would count. We would just add up. The next field is your function, what you're actually doing. That's actually all that's in this one, so we only have the seed and the function. And the function signatures int. So the first two are parameters, it's these two, and then the return type's an int. And that's where we get our evens. So we were saying, take these two values, total and next, apply this function to them. If the or if it is even, add one, else don't add one, and that gives us a count. The equivalent regular code to that would be something like this: or count of evens equals 0 for each var in numbers, count of evens if is even in count of evens plus, we'll just do plus, and then we'll do count of this. So there we go. So there, that should be similar. Let's make sure we get the same thing, and we do. So those are similar equivalencies. This one's a lot harder to read at first, but I personally like Aggregate myself. But as you've seen there, I was reading the function signature as I went, so I don't use it enough to know it completely, but I do, and I've used it enough I can read the parameter there and like, okay, let's do it like this, and we'll adjust the function to do something. Although it was hard to make an example here. Another way I've used this was to add basically to act like a string.join, but for a very specific data type I use at work. But Aggregate made something a lot easier than doing how I would have had to do it like this. Even though it would have been similar to this, there was going to be a lot more code than this was. But yeah, we can do something like this. That's Aggregate. Let's see. Look through the list here and see what else there is. There's a repeat. Let's do it. I've never used it, so we're gonna learn what it is on the side. So let's do it looks like it'll be enumerable. Repeat. What it looks like. Element. And then a count. Let's do 42, and we'll do 42 times. See what that does. I don't know if this will work, but let's see. Now, let's do it. Let's do it like this. We'll do for each for x in this. Let's see if this works. Bet there's 42 there. It's too many to count. Let's reduce that count. Say 7. And it is. Okay. Yeah, so it just gives us a nice way to show a couple values. Let's say we skip 3 of them. Skip 3. So now we should just get 4. Yeah. Okay, so yeah, so it gives you a way to do some simple looping, and you can do some adjustments. So what was the value here? Was it or it's a T, so we should be able to pass something else. Let's do a string. Let's say hello world. Print out 4 of them. It does. Okay. So yeah, so that one's a neat one too. I actually haven't used that one before. Distinct. Okay, distinct. That one, but I don't think I've used distinct either. Let's do I think it'll be this. I think uses the distinct numbers. I believe so. So this will just give us the same numbers as we have. So for each var in distinct CWN. So this will just give us our same list of 10 values. It does. Let's do it like this. Let's make this a 1, this a 1, this a 1. So now we should only get to 1, 5, 6 through 10. Yeah. Okay. Yeah. So that one's just checking for distinct values, so values that don't match anything else. So that one makes sense. That seems like it's pretty easy. Is there any overloads? There is. Let's see what it takes. Oh, a compare. Okay. Yeah, so distinct pretty easy. That one's neat. Yeah, and I don't think I've actually used it before either. Intersect. Let's try that. Let's do our numbers here. Let's reduce this list. Let's say 2, 3, 4. I'm expecting it'll be a second one. Numbers 2, and let's say 4. Let's do 9, 8, 7, 6, and then 3, 7, 6, 5. Let's get a little bit of overlap, but not a ton. So let's see what this does. So for each var in numbers dot intersect. And I don't know if this is what this is going to do, so we'll see if this works. So this one there should be no intersections in. So let's see if it actually works like I'm thinking it is. So we get nothing. If we switch this to 3, then we have 1 intersection. It's a 4, good. If we do it, it's 2, 6, and 7. And those are correct. Okay, so yeah, so what that one's doing is it's just you're letting you see if you've done any set theory, it's basically letting you act like it's that. And some of the other ones distinct, we looked at except the other day. So it's basically just saying, give me the values that intersect, so the ones that are common between the two. Let's see. Any other ones we want to on the day? Sequence equal. CW sequence equals numbers 2. So I think this is just going to do exactly what it says. So it's going to check if these numbers match these numbers. Let's see. False. Now if we make this 1, 2, 3, 4. So now I expect this to be true. True. Try this. Let's try 4, 3, 2, 1. So now the numbers match, but they aren't equal. So I think that'll be false. False. Okay. So yeah, so that one seems to be doing what it seems like it's going to do. So it's just checking if the numbers are in the same order, the same numbers, and in the same order as you're given. Looking through the list, we've about covered most of the major things. We'll try union. So union, what I think it'll do is it'll give us a combination of 2 patterns. So let's undo this. I'll change this here to this number. let's try union. Let's see what we get for union. in numbers.union, and I believe it'll take a second, and it does. So I think what we should get here is 1, 2, 3, 4, 9, 8, 7, 6. So we'll see about that. And it is. Okay. So I would expect it doesn't do duplicates. So if we do a 3 here, I think we'll only see 7 values. 7. Yep. Okay. Yeah. So that one's pretty neat. So occasionally, again, with the other set problems, sometimes it'll be not, or sometimes you can just have numbers like that you'll need to combine like this, and there's a built-in way to do it. Let's see. Is there any other types? I don't see any others I want to cover. So there are a couple others. There's one dot single. So it just returns an int, so it returns just a value from it. So yeah, so it returns the only value in a sequence or throws an exception if there's more than one. So that's something to keep in mind. Else? Range. There's a min and max. I think we actually looked at those. They just give you the minimum or maximum number in something. We'll do this. Let's do MCW numbers dot min or max. So there we'll get 4. If we do min, we'll get 1. 4. If we do min, we get 1. There's an average. Again, I think we talked about these. 2.5 makes sense. There's a sum. 6, 9, 10. So yeah, so that's just some of the things we can do. There's one to check if it's empty. Numbers dot empty. Oh, there isn't. Default if empty, that's not going to be true. So it returns either numbers or an empty list, I think. Let's see. There's an empty. Is it enumerable but empty? Yeah, there we go. I don't know how to use it, but there's an empty. I guess it's here. There. So now if we capture that. Test. There. And now we would have an empty IEnumerable. If we do a for each for in and test CW, and what we're going to have there is nothing. But yeah, that's pretty much what I wanted to cover for LINQ. So that's actually pretty good stopping point. So there's we went through all of the different LINQ methods, not all of them, but we went through a lot of the different LINQ methods, and we've at least seen how they work, and hopefully it gives you some feel for how they work, and you can go read the descriptions here and put them together. And I think that's all we want to cover from it, though. So might try to actually do some projects using LINQ in the near future. So we'll see about that. So I think next I may want to I'll have to think on it. I may want to start looking at a few algorithms. So do a little bit more with the destruction algorithms next. We'll see. But this is pretty much what I wanted to cover with LINQ. So we'll call it here. This has been Programming with Shadow, episode number 2. In this lesson, we have looked through a few remaining LINQ methods. We've looked at Aggregate. We've looked at Distinct. We've looked at GroupBy. We've looked at Insert. We've looked at Join. I said there's a join left and a join right as well. I do not remember right offhand what those do, so we'll come back to that maybe next time. But we looked at Intersect. We looked at Repeat. I've never seen Repeat, but that's exactly what I thought it was going to do. So that was nice. We looked at SelectMany. Looked at Sequence Equal. And we looked at Union. So we looked at a ton of different things today, but all the goal here wasn't to go in depth, but just to show what they were and show how some basic usages. So this was their GroupBy or SelectMany. So yeah, so that we're going to call it there. So thanks for watching, and have a wonderful rest of your day.